Question number 7. This is a question about waves, and part A asks us, a laser produces a beam of monochromatic light. State what is meant by the term monochromatic. Okay, this is something you can memorize or you can understand on the go. So we are talking about light, first of all. Secondly, here we can see the word chromatic, which relates to color, and mono is a prefix which basically means one. So this word means light which is made of one color. Because it is a laser, it only produces red light usually, and we can also say it is made of one frequency. The reason is because color and frequency, color exactly depends on the frequency in terms of electromagnetic radiation and in terms of light. So color and frequency are basically kind of the same thing for light. Question 7 part B. We have a wave in air. So over here we have a boundary that is between the materials air and glass. The above area over here you can see is air, and down below over here you can see is glass. Now we have a wave traveling in this direction shown by the black arrow, and these lines by the pencil are the wave fronts of that wave. Let's move on to part 1 of this question. We have to draw the wave fronts of the reflected wave. Let me trace out the path first. Okay, so the wave coming over here will be incident like this. There is a normal over here perpendicular to the boundary like this, and this angle over here is the angle of incidence that we know for sure. We have studied that the angle of incidence is always equal to the angle of reflection in the case of reflection. Therefore, there will be an angle over here which will be angle R, and the wave will look something. The wave will look like this, and now I'll draw the wave fronts. One thing to note is that the wavelength will remain the same. When a wave is reflected, wavelength always remains the same. Frequency remains the same. The only thing that changes is the direction. Moving on to part 2, this time we have to draw the refracted waves. I'll just write over here the thing to note, which is that angle I is equal to angle R always. Now let's think about the refracted wave. So we know that from air to glass, the glass of density is higher. As the density is higher, the speed of this wave will be lower. As the speed will be lower, wave will try to bend towards the normal. So over here, the wave should look something like this. It should follow a path something like this. Okay. Now, one more thing to notice is that the angle over here, let's call it F. Angle F is smaller than angle I. Now let's draw it. One more thing to notice is that the wavelength for the refracted wave is shorter. So I'll just write this wavelength as lambda f for final, and this one as lambda incident over here. The wavelength over here is shorter because the speed of the wave has been decreased and the frequency kept same. Part C. A transverse wave is produced in a long horizontal rope. Okay, so first of all we have a rope which is quite long. Rope which is long, and we have a transverse wave. What is a transverse wave? So basically, transverse wave is a wave which travels in the direction which is perpendicular to its disturbances. So one of the examples is a water wave. In a water wave, you can think that in a water wave, the molecules move up and down. So if this is a molecule, it will move up and down, but the wave actually goes through. Wave goes in this direction over here as indicated by this arrow, but the molecules are moving up and down, which is exactly perpendicular to each other. Rather, in sound wave, molecules are also moving longitudinally, and further the wave is also moving in this direction. So this over here is a longitudinal wave, and this over here is a transverse wave. Now we have to draw a diagram of how the rope will look when it has a wave, and we have to label two important features. Okay, this seems like an easy task. Let's draw the wave. Let's draw the rope first. This may be the rope looking like a sine wave, and this is the other end. At any point in time, the rope should look something like this. And if it was longer, maybe we can have more iterations over here. Okay, now what can be two important features? So first off, I can see that this over here can be an amplitude. Further, while this is the amplitude of the wave, another feature which I can see is the wavelength, which can be represented by lambda, which is this distance. I guess that's it.